Alright, so here's another video on solving trigonometric equations. This is the third one in the trigonometry lecture video playlist. Typically in a trig class or in a trig book, there's usually like 3 sections on solving trig equations. The first section is usually the easier ones, the basic ones, and then the second section is multiple angles, and then the last one deals with like quadratic type equations. So, you know, if you're watching this one and you haven't watched the other two, I would go watch the other two. They're right before this one in the playlist. So I would watch them, and you watch all 3. That covers everything in a trig class on solving trig equations. All right, so let's go ahead and get started. And you know, if you haven't watched the other 2, I would watch them before you watch this video. Okay, because it starts out simple, then it gets a little more difficult, and then it gets to this. All right, so we want to find all solutions in the intervals 0 to 360. And I'm going to work some of these problems where the angles are in degrees, some are going to be in radians. So if you've watched the other 2 videos, you know what you want to do is you want to figure out what quadrants your solutions are in, and then you want to find your reference angle and use your reference angle to find all your solutions. All right, so I've got sine squared equals 1. So this is square root property. This right here goes back to college algebra, when you had something like x squared equals 9, then you know x is equal to plus or minus the square root of 9, which is plus or minus 3. All right, so that's what we're using here, the square root property. So that's going to give me, I got sine squared equals 1, so that's going to be sine x is equal to plus or minus 1, so that equals negative 1, or sine x equals positive 1. All right, now remember what I've said is determine what quadrants, find your reference angle. But if you watch the other videos, you also heard me say if you've got sine or cosine equals 1, negative 1, or 0, that's one of the quadrantal angles like 0, 90, 180, 270, and 360. So you've got to memorize sine, cosine, and tangent of 30, 45, and 60. And I know you've heard that plenty of times if you've been watching my videos. Okay, but you've got to memorize those. And the sine of 0, 90, 180, 270, and 360. All right, so when you got negative 1 or 1, the sine or cosine equals negative 1, 1, or 0. That's going to be the 0, 90, 180, 270. So the easiest way to do that is just draw your basic sine graph and label it. That's 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2, which we know that's 0, 90 degrees, 180, 270, and 360. So we want to see where is sine equal to negative 1. Well, we know this is negative 1 here, and this is 1 here. Well, at negative 1, you see, there's our y value of negative 1. That's what? 3 pi over 2, or what? X is 270 degrees, because we're in degrees, okay? And then we want to see where does sine equal 1. So where is sine equal to 1? Well, that's right here at 90 degrees. And so there's your solutions. All right. So that's pretty easy there. Okay, that's not bad. So let's look at the next one. All right, so we've got cosine squared equals 1/4. So once again, we've got what? Square root property. So that's going to be cosine x is equal to plus or minus the square root of 1/4. So that's negative 1/2, or cosine x equals positive 1/2. All right, now don't try to do everything at one time when you're solving these. Just solve each one of them individually. Okay? So right now, let's just pretend like cosine x equal 1/2. Pretend like that's not even there. Just look at this one. Cosine x equals negative 1/2. Let's solve it. Okay? So we're looking at cosine x equal negative 1/2. So where is cosine negative? It's negative in the second and third quadrant. Okay? That's where cosine's negative. So remember, we determine what quadrant our solution's in. Then we need our reference angle. So remember, your reference angle is an angle in the first quadrant. All right? And remember, anytime you take the sine, cosine, or tangent of a reference angle, it's equal to positive. It's a positive answer. Because your reference angle is in the first quadrant, all the trig functions are positive in the first quadrant. So I need to first find my reference angle. So I've got cosine x prime. That's the notation I use for reference angle. The book that I teach out of, that's what it uses. You may see it in different books. You may see them use a line over it or hat or something like that. Okay, just depending on what book you use. Mine uses the little prime there. So the cosine of the reference angle is equal to positive 1/2. Now keep in mind, I'm just doing this to find the reference angle. So my reference angle is what? Well, the cosine of what is 1/2? Well, the cosine of 60 degrees is 1/2. That's my reference angle, but it's not a solution because my solutions are in the second and third quadrant. But I've got to find my reference angle to use it to find these two solutions. All right, so let's find x equals, now, let's find the reference angle. All right, well, not find the reference angle, but find our second quadrant angle. So we're in the second quadrant. All right, so here's the angle we're looking for. That's x. Here's our reference angle, 60 degrees. So we're going to get x is equal to, and that's going to be 180 minus 60, which is 120. And so 120, there's a solution. That's our second quadrant angle. Now let's look for the third quadrant angle. So that's here. There's our reference angle. And so x is equal to what? Well, we're going to go 180 plus another 60. And that's going to give us 240. So we got 240. So there's the solutions for this one. Now we've got to do cosine x equal 1/2, positive 1/2. So let's come over here. We got cosine equals a positive number. So that tells us our solutions are in the first and fourth quadrant. All right, so remember, find your reference angle. So let me ask you this. On this one, cosine equals 1/2. Is our reference angle one of our solutions? Yes, because one of our solutions is in the first quadrant and your reference angle is in the first quadrant. So I get x is equal to 60 degrees. That's my first quadrant angle because the cosine of 60 is 1/2. And that is also my reference angle. All right, so now I just need to find my fourth quadrant angle. So let's see what that is. There's fourth quadrant. There's x. There's my reference angle. So I get x is equal to 360 minus 60, which is 300 degrees. All right, and there's your answer. So this right here is a perfect example of, your trig function equals a positive, your trig function equals a negative. So you can see we found the reference angle on both of them. It just so happens that when it equals a positive number, your reference angle is one of your solutions. When it equals a negative number, you have to change this to positive and change this to your reference angle, get your reference angle, but it is not a solution. Okay? All right, let's look at the next one. Tangent squared equals tangent x. All right, so first thing I want to do is let's get that tangent x on the left-hand side. Let's get everything on one side, set it equal to 0. Now I need to factor. So I can factor out a tangent x. And so that's going to leave me tangent x minus 1 equals 0. All right. Now I just take each factor and set it equal to 0. So I've got tangent x equals 0, or tangent x minus 1 equals 0, which this is tangent x equal 1. All right. Now we're finding all the solutions between 0 and 360. All right, so take each one of them and solve them. All right, so tangent x equals 0. The tangent of what is equal to 0? All right, so there's a couple of ways that you can look at this, and I guess I'm going to go ahead and show you both of them. Okay, now remember, we're looking for everything between 0 and 360. Okay, now I know it says 0 and 360, but since we've already done a couple in degrees, let's just go ahead and switch over to radians. Okay, I mean, it's all worked the same whether you're in degrees or whether you're in radians. Now, if you look at the graph of tangent, remember the basic graph of tangent, it looks like this. So we can easily see that tangent is 0 at 0. Okay, that's one of our solutions, x equal 0. Now, remember, we're going from 0 to 2 pi. So I would have to actually extend this, and the period of tangent is pi. So pi plus pi over 2, that's 3 pi over 2. And then halfway between here would be pi. And so I know I would have this graph. So pi would also be a solution. See that? Pi would also be a solution. And then I'm still not quite up to 2 pi. See, I can go over another pi units. So that would actually be 5 pi over 2. And then we've got some values in here and everything. But, in the end, there's nothing else where tangent is 0. I mean, it is 0 right here, but this value is not between 0 and 2 pi. Okay? So that's kind of sketching the tangent curve and finding your solutions. But I think a way that would be easier to do that, to figure out where tangent is 0, is if we look at this. Okay, this is the graph of sine, right? But remember, tangent is equal to sine over cosine. All right, and if I sketch in the cosine graph, that's going to look like this. I mean, we don't need the cosine graph, but I just went ahead and put it in there. But remember, tangent, sine over cosine. So tangent is 0 whenever sine is 0. Remember, 0 over a number is 0. Well, 0 over any number but 0. Okay, we can't have 0 over 0, but 0 over some number that's not 0, that's going to give me 0. So really, all I need to do to figure out where tangent is 0, where's sine 0? Well, that's 0 here and here. And see, there it is, 0 and pi. And I think that's a little easier, figuring out where sine is 0. Okay, so that takes care of tangent x equals 0. Now, let's look at tangent x equals 1. Well, I've got tangent x equals positive 1. All right, so where is tangent positive? It's positive in the first and third quadrant. All right, so remember, we got to find our reference angle. So let me ask you this. Is the reference angle a solution? Yes, because one of our solutions is in the first quadrant. So that means our reference angle is a solution. And so I get x is equal to the tangent of what is 1? Positive 1. Tangent of x is tangent of what is positive 1? Well, that's 45 degrees, which is pi over 4. All right, that's my first quadrant solution, and it is also my reference angle. So now that we have our first quadrant solution, let's find our third quadrant solution. There's pi over 4, and so x is equal to pi plus pi over 4, and that is 5 pi over 4. And there's my answer. All right. And like I said, look, watch the first video, the second video, and then this one, okay? It's going to be so much easier if you do it like that. All right, so how about this one? So this is quadratic, right? We got to factor it. It's kind of like when you had this, 2x squared minus 3x plus 1. See, the only difference is instead of x, we've got sine. And, you know, if we factor this, that's going to be 2x, x, 1, 1, and they're both going to be minus. So that's how that would factor. Well, this is the same thing. Look, that's going to be 2 sine x minus 1 times sine x minus 1 equals 0. All right. So then we set each factor equal to 0. So 2 sine x minus 1 equals 0, or sine x minus 1 equals 0. So I get sine x equals 1/2, or sine x equals positive 1. All right, so here you go. Now just solve each one of them individually. Let's look at sine x equal 1/2. Let's look at that one first. So I've got sine is equal to a positive number. So our solution's in the first and second quadrant. We find our reference angle now. So is our reference angle a solution? Yes, because one of our solutions is in the first quadrant. So I'm going to get x is equal to, well, the sine of what is 1/2? The sine of 30 degrees. But since we're in radians, that's pi over 6. All right, there's my first quadrant solution. Now I need to find my second quadrant solution. So there's x. There's my reference angle. And so x is equal to what? Pi minus pi over 6, which is 5 pi over 6. And there's the solution. Now sine x equal 1. Now remember what I told you earlier in the video, when you get sine or cosine equals 0, 1, or negative 1, just sketch the graph out if you don't have it memorized. So there's pi, there's 2 pi, there's 3 pi over 2, pi over 2, and 0. So where is sine equal to 1? Well, there's 1 right there at pi over 2. And there's your answer. All right, so see, this really isn't that bad. And if you watch the very first video, you've heard me say this, and now you can see it, that the first video is so important to understand that one, because look, the first video basically starts with this and say, okay, solve. All right? But as we progress, we've got to do other things to get it to look like this. Okay? All right. Here's another one. All right, I got cosine squared minus 0.2 sine x equals 0.9. All right, so here we've got some problems here. So the first thing is we've got some decimals in there, which we don't like. So that's probably going to make it kind of difficult to graph. I mean, not to graph, but to solve. And then we've got a cosine and a sine in there. And really we want them all in terms of one trig function. I mean, you don't have to have that all the time, but in this case you do need that. So I need to either get it all in terms of sine or all in terms of cosine. And I can change cosine squared into sine squared, because remember, sine squared plus cosine squared equals 1. So cosine squared is equal to 1 minus sine squared. You see that? So I can replace cosine squared with 1 minus cosine squared. So let's do that. 1 minus sine squared x minus 0.2 sine x equals 0.9. And let's bring the 0.9 over. So I get negative sine squared x minus 0.2 sine x. And then I've got, see, I'm subtracting 0.9 to both sides. And so I got 1 minus 0.9 is equal, plus 0.1 equals 0. So I got everything to one side of the equal sign. Okay. So now, what can I do? Well, I can solve this. Does it factor? I don't think it factors. So let's, how about we use quadratic formula? Okay. And I think what I'm going to do before I use the quadratic formula, I'm going to divide everything by -1, because typically whenever we're solving a quadratic, we don't want a 1 in front of the squared term. I mean, we don't want a negative in front of the squared term. All right. So do you have to do that step? No, you don't have to, but it's just, to me, it's just easier to do. All right, so now let's do the quadratic formula. So I get sine x is equal to negative 0.2 plus or minus the square root of 0.2 squared minus 4 times a times c all over 2 times a. And so I get sine x is equal to, now I'm not going to do all this arithmetic out and everything. I'm going to put the answer down. So this is basically negative 0.2 plus this divided by 2. And so when I do that, I get 0.2317. That's rounded to 4 decimal places. Or I get sine x equals, now this is negative 0.2 minus the square root of this, and then all of that divided by 2. That's going to give me negative 0.4317. All right, so there we go. So that's what we get. I mean, you see, it's the same thing. Every time, what are we doing? We're getting the trig function equals a number. The trig function equals a number. And that's exactly what I did here. I've got the trig function equals a number. The trig function equals a number. It's just I had to do a bunch of other stuff to get it to that. Okay? And now this is the same thing. We work it now like we have been all the other problems. So let's determine what quadrant our solutions are in. Well, for the first one, I'm in the first and second quadrant. See that? I'm in the first and second quadrant. So is my reference angle a solution? Yes. So x is equal to, so I've got to do the inverse sine of this. Now, the important thing here is when you take the inverse sine, make sure your calculator is in radians because we're finding our angle measures in radians. So that's second sine 0.2317, and that is, and I'm going to round these to 2 decimal places, 0.23. All right, that's the angle, 0.23 radians. That's my angle measure. So now I've got to find my second quadrant angle. So let's come down here. There's my second quadrant angle. There's x. There's my reference angle, 0.23. So x is 180 minus the angle, but since we're in radians, pi minus 0.23. So let's see what we get. Pi minus 0.23, that is 2.91. And so there's the solutions to the first one. All right. Now let's find the solution to sine x equal negative 0.4317. All right, so we've got sine is equal to a negative number. So that tells us our solutions are where? In the third and fourth quadrant, right? So we need to find our reference angle. Is our reference angle a solution? No, but we still got to find it so we can find these two angles. All right, so to find the reference angle, let's find my reference angle, and that's going to equal a positive 0.4317 because the sine, cosine, or tangent of a reference angle is positive. So I get my reference angle to be, and so let's see, second sine 0.4317, that is 0.45. That's my reference angle. And keep in mind, it's not a solution because my solutions are in the third and fourth quadrant. So now I've got x is equal to, all right, so let's find our third quadrant solution. There's x, there's my reference angle, 0.45, and so x is equal to pi plus the reference angle, pi plus 0.45, and so that is pi plus 0.45, that is 3.59 radians. All right, so there's the there's my third quadrant angle. Now let's find the fourth quadrant angle. So that's x, my reference angle, 0.45, and so x is equal to, that's going to be what, 360, but we're in radians, so 2 pi minus the reference angle. So 2 pi minus 0.45, that is 5.83. And so we got 5.83. And there's your solutions. So you can see the process of doing this, it's all the same once you get to this point right here. This is going to be the difference in all the problems, is this part of how you get to here. But once you get there, it's all the same. All right, so This one's the last problem. All right, and I think for this one, let's go back to degrees. Okay, let's go back to degree measure. Now we've got tangent 3x plus 1 is equal to the square root of 2 times secant 3x. All right, so we need to get everything in terms of one trig function. So, well, I don't know anything that can get me from tangent to secant or secant to tangent, but I do know things that can get me from tangent squared into terms of secant squared and secant squared into terms of tangent squared. So it would really be nice if these things were squared, the tangent and secant. All right, so we got to get these things squared. So, well, let's just square both sides. How about that? So that's going to give me, now remember, this is what? Tangent. Well, yeah, let me go ahead and write it all out. Tangent 3x plus 1 times tangent 3x plus 1 equals 2 secant squared 3x. Okay, square root of 2 squared is 2, and then this squared is secant squared. And then remember, this is tangent plus 1 times tangent plus 1, so I need to FOIL that out. So that's tangent squared 3x plus 2 tangent 3x plus 1 equals 2 secant squared 3x. All right, so there we go. Now remember, I need to get everything in terms of tangent or secant. Well, let's get everything in terms of tangent. How about that? So that's going to give me tangent squared 3x plus 2 tangent 3x plus 1 equals 2, and then what? Well, remember your identity. Tangent squared x plus 1 is equal to secant squared x. That's one of your Pythagorean identities. So secant squared is this. So that's going to be 2 times tangent squared x plus 1. All right. So all I did, I replaced, that wasn't good, was it? That should be tangent squared 3x plus 1. So all I did is I replaced this with this right here. All right. Now, let's clear the parentheses here. So that's going to be tangent squared 3x plus 2 tangent 3x plus 1 equals 2 tangent squared 3x plus 2. All right, so let's get everything to one side. So I think I'm gonna move this term, and this term to the right hand side. So if I subtract tangent squared to both sides, that's going to leave me with tangent squared 3x, and then I move this one to the right hand side. That's minus tangent 3x, and then subtract 1 to both sides. That's going to be what? Plus 1, and that equals 0. Now we got a factor. So this factors into what? Tangent 3x minus 1 times tangent 3x minus 1 equals 0. So you can see we've got the same factor, don't we? We've got the same factor. So I just need to set one of them equal to 0. And now just solve. So I get tangent 3x equals 1. See that? Tangent 3x equals 1. All right, so I've got tangent is equal to a positive number. Now, the other thing here, if you watch the video prior to this one, this is at multiple angles. Okay, that's the second video. We go over this in more detail than what we are in this video. But just a quick reminder, this is 0 to 360, but that is for x. Okay, so what that's saying is that 0 is less than, or 0 degrees is less than or equal to x less than 360 degrees. See, we need 3x here. That's our angle, 3x. So if I multiply through by 3, that's 0 less than or equal to 3x less than, and then we have 360 times 3 is 1080. So I'm looking for all the solutions from 0 to 1080. And if you've watched the video previous to this one, remember we're going to go around 3 times. Okay. All right. So let's see what we've got here. We've got tangent is equal to a positive, so that means I'm in the first and third quadrant. Okay. Remember, we got to find our reference angle, but is our reference angle a solution? Yes, it is a solution because one of my solutions is in the first quadrant. And so I get 3x is equal to, well, the tangent of what is 1? Well, that's 45 degrees. Remember, we switched over to degrees. You can do this in radians, that's fine, but we're going to do it in degrees. All right, now I need my third quadrant angle. So there's my third quadrant. There's my reference angle, 45. So x is equal to 180 plus 45, which that's what, 225. So that's 225. All right, so remember, I've got my first quadrant angle, that's 45. And then, and like I said, you really need to watch the first and second video because that's all the second video is these multiple angles. Okay, so go back and watch those because I'm not going to go into as much detail in this video on the multiple angles. All right, so basically what we got to do is go around 3 times, right? And we've already been around once getting the 45 and the 225. So I've got the 45, so I need what, 45, and I need to go around again, so I need to add 360, right? So that's going to be 405, and so there's a solution, 405. And then I need to go around this one again, so I'm at 225, so from 225 I need to go around again, so I'm going to add 360, and so I get 225 plus 360, that's 585, and so there's 585 is a solution. And then I'm going to jump back to this one, and I went around twice on both of them. Now I have to go around a third time, so I got to add 360 again. So 405 plus 360. So 405 plus 360, that is 765. So we're at 765. And then I got to go around again here, so that's 585 plus 360. So 585 plus 360, that's 945. That's 945. All right, let me get this out of the way. All right, so there's all our solutions. Now, let's erase this because we don't need this anymore. If you need to look at that, you can rewind the video and copy it down on your paper. But let's look at this. So what I want to do real quick is I want to write the original problem down again. So I get tangent 3x plus 1 equals the square root of 2 secant 3x. All right. All right, so So what we can do here is, of course, we're going to divide through by 3 because we need to know what x is. But one thing you've got to keep in mind is, if you remember from algebra, when you were solving equations with square roots, what did you have to do? You had to square both sides, right? You had to square both sides to get rid of that square root. And then if you remember, at the end of that, you had to do what? You had to check your solutions. You had to actually plug all your solutions back in to make sure they worked. And that's the same thing here. We squared both sides. Okay, we squared both sides. So we have to check our solutions. Now, what I'm going to do here is we're going to eliminate some just right off the bat. Okay, so I know, without even doing anything, I know this, and this are not a solution. Okay, I know those are not solutions. And how do I know that? Well, good question. Let me show you. There's 225, right? And then when I went around again, when I went around a second time, I got 585. So 585 is in the third quadrant. And then I went around a third time, and 945 is in the third quadrant also. So all of these angles I have crossed out are in the third quadrant. So if we plug this in, okay, so if we plug in 225, 585, and 945, I don't even care about the exact answer right now. Okay, I don't even care what I get exactly when I plug those in. What I'm looking at is 225, 585, and 945. When I plug that in and I do the tangent of 225, the tangent of 585, the tangent of 945, and also the secant of those three angles, the tangent of those angles is positive. The secant of those angles is negative, right? Because we're in the third quadrant. Secant's negative in the third quadrant. So this side's going to be positive. This side's going to be negative. There's no way they can equal each other. So that saves you a lot of time of plugging those in just by knowing that. Okay, so I eliminate those right off. Now let's check the 45. Okay, so you see 3x. 3x is 45. So I've got tangent of what? 45. So tangent of 45 plus 1 is equal to square root of 2 times the secant of 45, right? All right. So the tangent of 45 is what? 1 plus 1, and that's 2, right? And then let's look at this. The secant of 45. What's the secant of 45? Well, the secant of 45 is equal to 1 over cosine 45. So that's equal to 1 over square root of 2 over 2, which that's 1 times the reciprocal of that. So that's just 2 over square root of 2. You see that? So that's square root of 2 times 2 over square root of 2. Square root of 2's cancel, so I get 2 equals 2, and that checks. So that tells me that's a solution. And I'm not going to do it, but you're going to get the same thing as if you put 405 and 765. You would just have to plug those in. But we know that they're going to work, and how do we know that? Because there's 45 degrees, right? There's 45. Well, when I went around the second time to get the 405, it's the same terminal side. And then when I went around here and then went around another time and got the 765, they're all landing here on the same terminal side. So they're all going to check. All right. And so those are my solutions. And so now I need to find x. So that means I've got to divide everything by 3. And so I get x is equal to 15 degrees and then let's see, 405 divided by 3, that's 135, and then 765 divided by 3 is 255. And there's your solution. All right, so that problem was a little more involved. It was a little more complicated than all the other ones, but look, you see all the work we had to do right here, and it all comes down to getting it. Trig function equals a number. That's the whole key to this, is getting the trig function equals a number, and then you work every problem just like we did in the first video. That's why I keep telling you to go back and watch that first video. But this is the difference. We had to go through all of this to get it into this form. And that's what's going to be the difficult part about the problems in this video, or in this section of a trig book, is getting to that point. And we had to do some of that in the second video, but those were more the multiple angle, going around like we did here. But like I said, if that right there is giving you problems, go watch the second video for solving trig equations. I think it's called trig equations involving multiple angles. Okay, watch that one. That'll help with this. All right, so I hope this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all later.